Hey guys, welcome back to a brand new video. Today we're going to be talking about conditional probability and Bayes theorem. So conditional probability is the idea of the probability of an event occurring given that another one has already occurred. So we can write conditional probability as the probability of, let's just say event B given event A has occurred is equal to the probability of the intersection of events A and B over the probability of event A. And we can actually rewrite this in a number of ways just by rearranging different parts of the equation. So for example, we can say that the probability of the intersection of A and B is equal to the probability of B given A times the probability of A, and etc. You can just rewrite this in multiple ways to solve for just whatever you're trying to solve for. And so an important thing to note about conditional probability is that the probability of A, given that B has occurred, so this is a complement of the probability that A not has occurred given B. And so we can think of this as the sample space being B. So let's just say that visually we have this space, and that this space is just the chance that B has happened. So this is a sample space B. And so if we have A, given that B has happened, we can visualize this by saying like, this is A, and then on the other side we have A not. So just like, if this is A, then this is not A. And since this is all contained in a sample space of B, we can say that A is the complement of A not in this sample space B. Therefore, the probability of A given B, so the probability of A in the sample space B, so A in the sample space of B, is the complement of A not given that B has happened, aka in the sample space of B. So visually we can see that A is the complement of A not, therefore this statement is true. And therefore we can also say, that the probability of A given B is equal to 1 minus the probability of A not given B. And this is just a property of what a complement is. So relative to conditional probability, we can also talk about a concept called Bayes theorem. Bayes theorem is basically used for finding the conditional probability when we know its reverse probability. And so we can write this by saying that the probability of, we'll just say event 1 given B has occurred is equal to the probability of B given event 1 has occurred, so the reverse of what we're trying to find, times the probability of event 1 occurring all over the total probability that event B has occurred. So this will just be the probability of B given event 1 has occurred times the probability of event 1 plus the probability of B occurring given event 2 has occurred times the probability of event 2 plus etc. all the way to event K, however many events there are. And so a couple important properties to point out, we're actually using the total probability rule in the denominator. And so this is the total probability that event B has occurred, given that event 1 has occurred, event 2, etc., all the way to event K. And we can also note that these events, it's probability of event 1, probability of event 2, all the way up to, however many events there are, they're all going to sum to 1. And this is because these events are mutually exclusive, and since it's the total probability of B, we're going to count for B happening in all events that exist. And so the probability of all events that exist all summed together is equal to 1. Another cool thing to note, just a good thing for checking your work, is that in your numerator, you're going to have the probability of the reverse of what we're trying to find, since this is a known value. And this component in your numerator is actually going to be equal to the first component in your denominator. So that's just another nifty way to check your work. All right, so here's a classic problem. We have a box that has 3 blue and 2 red pens. Another box has 2 blue and 5 red pens. We want to draw a pen, and we find that it's blue. So what's the probability that it came from the first box? So let's try to visualize this. So let's say we have our first box, and it's, we'll just say, here's our box. We'll just call it box 1. And we've got 3 blue and 2 red. So 3 blue and 2 red. And we have another box. We'll just say it's box 2. And we know that has 2 blue and 5 red pens. So we draw a pen and we know that it's blue. So by looking at each box, we know that each box has a half chance of being chosen. So the probability that we choose box 1 is 50%. The probability that we choose box 2 is also 50%. So we're going to try to find the probability that this blue pen that we know that is blue came from box 1. So we know it's blue. We don't know what box it came from, but we want to see if it came from box 1. So we're going to find the probability that, we're trying to find the probability it came from box 1. So we'll call it box 1, given that it's blue. And we can say it's given that it's blue because we drew a pen and we know that it's blue. So we'll say blue, given that it's blue, is equal to, well, let's see, do we know the reverse probability? So the reverse probability would be the probability that the pen is blue, given that it came from box 1. And so the probability of that, we do actually know. We're going to find that since there are 5 pens in box 1, the probability that it's blue, given that it's from box 1, is just 3 out of 5. And so we can say that this equation is equal to the probability that it's blue over, or given that it's from box 1, times the probability that we choose box 1. Oh, and the reason why we can use this, the reason why we can use Bayes' equation is because we know that the reverse is true. And so, just to write out the rest of the equation, probability that it's blue, given box 1, times probability that it's from box 1, plus the probability that it's blue, I'm just going to use shorthand now, given that it's from box 2, times the probability that we choose box 2. All right, and so we know that the probability of choosing a blue from box 1, if we just look at box 1, it's 3 out of 5. So just to plug in the numbers for this, we're going to get 3 out of 5 times the probability that we choose box 1 is just, as we said before, it's 50% between choosing box 1 or box 2. It's 50-50. So we'll do 1 out of 2 all over, and since this since this component of the numerator is the same as the first component of the denominator, we can just rewrite this first part. And now we have the second part, probability that it's blue, given that we're choosing from box 2, again, is just, out of box 2, we have 7 total pens. So the probability that it's blue is just 2 out of 7, times the probability that we're choosing from box 2, which again, it's a 50-50 chance of choosing box 1 or box 2. So we'll again use 1/2. And so if we compute this out, we can say that our answer is going to be equal to 21 over 31. That's our final answer when we compute this out. And so a couple things to note just about how we set this up and how you can go about double checking your work is by asking first, can we even use Bayes' theorem? That is yes, because we do know the reverse probability. We can check that we use Bayes' theorem correctly now. And so just a way that we can check our work is by asking, do the probabilities of the mutually exclusive events in the denominator sum to 1? And so we're going to be looking at the probability of choosing box 1 and the probability of choosing box 2. So do these values sum to 1? And they should, since they're mutually exclusive events. And so we can look here, say 1/2 plus 1/2 is equal to 1. Another way that you can check your work is by making sure that the value of the numerator is equal to the first component in the value of your denominator. And so are these the same? Yep, you can check yes. And yeah, that's just a simple way that you can check your work real quick using Bayes' theorem. And that's all for today. Thanks so much for tuning in, and I'll see you all next time.